Good morning. For those of you who know Kopin, we're best known for our OLED and LCD microdisplays. As a company, we're entirely focused on head-worn wearables. And what we've certainly seen is that one of the critical missing pieces of great head-worn devices is a good user interface. So that's what I'm here, a good voice interface. So that's what I'm here to talk about this morning. For the human-to-machine interface, we've come an awfully long way in the past, say, 35 years, from the very, very tactile keyboards, now more and more toward the voice interface. And it's clear that voice interface has some considerable advantages over the touch-based interfaces. It's better when it works. So first and foremost, a voice interface is hands-free and it's eyes up. And that brings some huge advantages. First, it's easier. You don't have to take a device out of your pocket or turn to some other device and focus your attention on it. Second, it's a lot safer because of that. You remain aware of your surroundings the whole time that you're interfacing with your device. And it's much faster. You know, the typical, a good texter, for example, will text maybe 40 or 50 words per minute, but we speak about 140 or 150 words per minute. So it's faster. And on top of that, it's much more of the moment. There's no physical barrier to expressing your thought or your idea. You just say it. And from that standpoint, it's much more fluid. It's much more natural to use. So as I said, a voice interface is much better. It has these advantages when it works. If you're anything like me, that's what your relationship looks like today with your voice interface. And maybe I'm sharing a little bit too much here, but I'm currently in a little bit of a spat with my voice interface on my phone. I haven't talked to her for about 3 days, and it's because she hasn't been listening very well lately. And so I think we've all experienced that kind of issue and frustration. A voice interface is wonderful when it works. You say it, and voila, there it is. It's incredibly frustrating when it doesn't work. And so while I know my behavior toward my phone and my voice interface is completely irrational to get frustrated or have that feeling toward a machine, it's also irrational because the issue really is not with the voice interface itself. And so whether you use Siri, Google, Alexa, Cortana, Nuance, any of the devices, any of the speech engines are actually very, very good at what they do. And they're getting better all the time. The issue is when you give each of these speech engines a good, clean voice signal, they do their job very reliably, very well. The issue is really not their fault. The issue is noise. Noise is the problem. When you encounter your speech interface not working well, it's almost always because of noise. The world wants and needs a reliable voice interface, whether it's home, whether it's at work, for IoTs, whether you're in the car. It doesn't matter. You want a speech interface that is reliable and that you can count on when you're working with it. All of these applications can benefit from what I talked about before, the hands-free, heads-up, natural and fluid elements of a voice interface. And each one of these application spaces has its own needs and requirements that need to be considered when designing products for the specific use case. They're in different noise environments. They have different methods of how they're worn, how they're used, and where they're used that need to be taken into consideration. So let's focus down on speech recognition today. And as I said at the beginning, Kopin is very, very focused on head-worn wearables. And so that's where I'm going to concentrate here. So let's look at how speech recognition works today in head-worn wearables. In working with our customers, we've worked with and tested many, many, many head-worn devices. And basically, here's where they stand today. Speech recognition, or ASR, today in a quiet environment typically is anywhere between 90 and 92% accuracy rate. When you start to introduce noise, which often in our lives there is noise, whether it's in a work environment or whether we're at a restaurant or on a busy street, the performance drops off dramatically. And again, typically we see somewhere between a 40% and an 80% accuracy rate in even moderate noise environments. And obviously that is somewhat dependent upon the specific type of noise, the specifics of the device, and that sort of things. But we find that it all lands somewhere within this range. And so you have to ask yourself, is that good? I can't think of any other product that I would ever use where if it worked 90% of the time, I would accept it. If you got in your car and it started 9 times out of 10, you wouldn't keep the car for very long. So the good news is it's gotten better over the past several years, and it continues to get better. But it's got to get really, really good for people, whether in the work environment or in the consumer environment, to really embrace a voice interface and rely on it as their main interaction interface with their devices. So what's required to earn a customer's love of their voice interface? And there's a couple of critical things. So the first is a great product design. Now, when I'm talking about voice interface, that may seem a little strange that I'm highlighting great product design, but that is a critical feature in a great voice interface. At Kopin, our CEO, John Fan, has 5 rules for developing great AR headsets. The first one of them is human first, technology second. And so what that means is, first, for something that I'm going to wear on my head, it needs to look good. If it looks ridiculous, I'm not going to wear it. And second is to make the technology as transparent as possible to the user so that they don't have to think about how they interact with it. They don't have to use their hands to interact with it. Make it as simple as possible so it's as fluid and natural for the user as possible. And one other thing about the industrial design is in the enterprise world, we find that our customers often sort of dismiss industrial design and say, oh, it's for work use. Of course they'll wear it. That's not true. In work, people still care about how they look. We do a lot of work with the military, with law enforcement, and even those folks who you wouldn't think would care, they care. They want what they wear on their head and on their body to look good. So don't underestimate that on the enterprise side of things. The second critical piece to earn a customer's love of a voice interface is certainly reliability. If I can't rely on it, it doesn't do me any good. If I give, for example, a speech text, but then I have to hold the device, look at it, and proofread it, and manually correct it, then what's the point of having a voice interface to begin with? I may as well just pick up the screen and type it myself. So it's got to be reliable. So the key question that we need to be asking ourselves is, how do we, in this industry, design devices that have better voice interfaces that our users are going to love? And at Kopin, we've solved this question specifically for head-worn wearables. So let's take a look at that. First is, again, when we work with our customers, we see 2 big issues that are very, very underestimated and underappreciated. So the first is the acoustic design of the device, and the second is the noise management. As I said at the beginning, noise is the most common problem for why a speech interface fails. So first on the acoustic design, the most important thing to keep in mind is it's a system. It needs to be thought through and designed from the ground up. It's not just an assembly of audio components put onto a device. It's important also to recognize that the acoustic design affects that other item that I mentioned that was so important, which is the industrial design. Where you place your microphones and how close they are to the mouth and how they affect the industrial design of the product are very, very important to think through. And I'll talk a little bit more about that in a moment. The second piece here is it's very difficult to get the balance between the industrial design and the audio performance. They often conflict directly with each other. From an audio design standpoint, you want to have the microphones right down in front of the mouth, as close to the mouth as you can. But obviously, from an industrial design standpoint, the designers aren't going to like that so much. So there are trade-offs in debates that need to take place within the development team. And very important is to really understand the use case, who's using it, where they're using it, how they're using it, to be able to make knowledgeable decisions about those trade-offs. There's lots to consider, and no, I'm not going to go through all of this, but there's lots to consider in your acoustic design. And the two things that I really want to stress here are, number one, plan it from the very beginning. Make sure you understand the use case, make sure you understand your customers, get as much input from your customers as you can, then test it and revise it. If this is a first-generation product, you're not going to get it right the first time. So the sooner you plan it, the sooner you test it, the more you'll learn and the faster you'll learn to be able to iterate and get it right. We've seen that time and time again. The second is involve the right people right from the beginning. As I said, there's trade-offs that need to be made. So you need to get your marketing people, who are the ones who are worried about the customer view of it the most, your marketing people, your audio engineers, your electrical engineers, and your industrial designers all together to work through what trade-offs you're going to need to make along the way. The second underestimated issue that I talked about, that again we see this with the customers that we work with all the time, is noise management. And I call it noise management specifically rather than noise cancellation, because it's more than just noise cancellation. So in short, today's noise management systems generally fail. That's why, as I was talking about at the beginning, that part of our voice interface that we hate, the failures are generally because of noise. And there's a few misconceptions that we see all the time as well. The first is that folks believe that a higher SNR leads to better voice recognition. It doesn't necessarily lead to better voice recognition. And similarly, folks believe that better voice quality for human-to-human communication also leads to better voice recognition. That is sometimes the case, but it's not always the case. And so the key here is to look beneath that at the typical noise cancellation software. Yes, it creates a higher signal-to-noise ratio, and often it improves the qualitative human listening performance, but it also often introduces distortion to the voice signal. And so as humans, that's okay for us to process. We usually filter that out in our unconscious that we're even doing so. So it still sounds good with the higher SNR. But when a machine is what's listening, that doesn't always translate to better, more accurate speech recognition. And so it's important to really understand not just the human listening aspect of this, but how a machine will hear the voice signal. And so at Kopin, we've developed what we call the whisper technology. And again, this is us focusing on that missing piece that's required to make great head-worn wearable products. So we designed this specifically to deliver reliable speech recognition even in the very noisy environments that as consumers we find ourselves in, and very typically in the work environment is often very noisy as well. And what we find is, depending upon the type of device and the specifics of the conditions, is that we typically get anywhere from 2 to 4 times better speech recognition accuracy. That's a huge difference in terms of a user's satisfaction with the product and the frustrations that they have to go through to use the product. And moreover, that type of better performance is in significant noisy environments. So anywhere from 75 dB, which is maybe a very busy, loud office environment, to 80 to 85 dB is a noisy city street or a typical restaurant environment. 90 dB, sustained 90 dB, you need hearing protection to be in that. So that just gives you a framework for how loud this is. And our belief at Kopin is that's the real world. That's where we live. And so the speech interface has to be able to perform under those conditions. Our technology, it works with any speech engine, any operating system, any processor platform. That really doesn't matter to us. So I won't go through all this, but the core of the Whisper technology is really how we take a holistic approach to understanding the speech and the noise environment that the device is operating in. So we do dynamic analysis of the noise and the voice activity in the time, frequency, and spatial domains simultaneously. And we do that all at about 16,000, sampling that about 16,000 times per second. And so then the key to it is, once we have that information in modeling, is we use a unique beamforming method to maximize the SNR, but without introducing distortion. We use voice activity detection to differentiate the voice, and then we use what we've called the voice extraction filter, which is a proprietary Kopin technology, to separate the voice from the noise. So in essence, we really don't do anything to process the noise the way most noise cancellation systems work. We fundamentally differentiate between what is the voice and what is the noise, and we leave the noise behind while we extract the voice. And the result of that is that we are able to then feed the speech engine a nice, clean, linear voice signal that it's able to understand. So I'm going to show you a video, about 30-second video, and I need to explain it a little bit up front, because essentially all you'll do is you'll see me and you'll hear a lot of noise. And so I'm wearing a pair of AR glasses that have 2 microphones built in and our Whisper technology. And there's a noisy, I think it's an 80 dB babble noise in the background. And what you'll see is I'm holding a Surface tablet. And what you'll see is, as I'm speaking, you won't be able to hear me, but as I'm speaking, you'll see the tablet responding to the commands or to the dictation, the sentences that I'm saying as well, even in the noisy background. So go ahead and play the So from Kopin's view, that's how a voice interface should work. It should be robust enough to be able to operate accurately in that kind of a noise environment. And I think you'd agree that, in your experiences to date, that's probably not the case. So in closing here, I want to read for you a quote from Andrew Ng, the chief scientist at Baidu, from a year or so ago. What he said is, as speech recognition accuracy goes from, say, 95% to 99%, all of us in the room will go from barely using it today to using it all the time. Most people underestimate the difference between 95% and 99%. And I couldn't agree with him more. You think of that in terms of your own life and the device that you use, you want it to work reliably. And when it does, you love it. So as you plan your products and develop your voice interface, if you want to take your customer experience from this, what it is today, to something that looks more like this, we'd like to help you. Please come see us. We're at the booth here out in the exhibit hall, and we'd love to help. Thanks very much.